Almost every people who've ever looked up and wondered how it all began told the same strange story, that in the beginning there was a sound, a word spoken into the dark, a song that called the world into being, a single humming note that everything else grew out of. They lived on different continents. They never met. Most of them never knew the other existed. And still, again and again, they reached for the same idea, that creation began not with sight, but with sound. For most of history, that was just poetry, a beautiful thing to say. But in the last few decades, cosmologists worked out what actually happened in the first moments of the universe, and they found something no one was expecting. The early universe really did ring, not as a metaphor, as physics, real pressure waves, real sound, moving through everything there was. And the fingerprint of that first sound is still here, frozen across the entire sky. We can measure it tonight. So stay with me, because by the end of this, you're going to see the first sounds the universe ever made, and see why so many people, with nothing but their own eyes, somehow got there first. Let's begin where the stories begin, with the Word. In the beginning was the Word. That's how the Gospel of John opens. In the original Greek, the word was logos, which means the word, but also reason, the ordering principle, the thing that comes first, and everything follows from. A few hundred pages earlier, Genesis opens the same way. Creation doesn't begin with a hand or a tool. It begins with a voice. And God said, "Let there be," spoken out loud. Hold on to that shape. First the utterance, then the world. Because now I want to talk to you through what the physics actually says. Somewhere around 13.8 billion years ago, the universe begins. Unimaginably hot, unimaginably dense, smaller than anything. And in this first fraction of a second, it does something violent and strange. It expands faster than you can picture. We call it inflation. Now, here's the part that matters. Before inflation, there were tiny quantum flickers, the small ripples allowed by nature. Here, a little more, there, a little less, and those flickers weren't a flaw. They were unavoidable, down to the smallest scale. There is a law that won't let nature hold perfectly still, not even empty space. There is always the faintest tremor in it. A perfectly smooth, perfectly silent universe was never even possible. Then inflation takes those microscopic flickers and stretches them across the whole sky, blows them up to cosmic size, a patch far smaller than a single atom, stretched in the tiniest sliver of a second to something like a light year across. I want to be careful here, because this is where it is easy to overstate things. This is not yet the sound. There is no ringing yet. What inflation leaves behind are seeds, a faint, uneven pattern laid down across everything, slightly denser here, slightly emptier there. But those seeds are the whole story, because a perfectly smooth universe would just sit there, silent, nothing to push against, nothing. An uneven universe is a different thing entirely. An uneven universe can move, can pull, can push back. The seeds are what the sound will need to have something to play. So the old story said, first the word, and the physics says, first the seeds, the faint, uneven pattern that everything to come would build on. Not the same claim. I'm not telling you Genesis predicted inflation. It didn't. But it is a strange rhyme. The deepest thing we can say about the beginning is that something had to come first and give the rest its shape. There's a phrase in the old Sanskrit text, Nada Brahma. The world is sound. Not the world has sound in it. The world is sound. Vibration first, and matter as something vibration does. They put a single syllable at the root of it. The primordial hum. The cosmos is still sounding. For thousands of years, that was philosophy. Now watch what the universe actually does next. After inflation, the young cosmos settles into a state we can describe very precisely: a blazing fog. Light and matter, packed so tightly together, they behave like a single fluid. And they really were locked together. Light couldn't travel, couldn't cross a room, couldn't cross an inch without slamming into a loose particle and scattering away. So the light stayed trapped, pressing on the matter, and the matter, thick with all that trapped light, dragged on the light. Neither could move without the other. One fluid made of both. And this fluid has the two things anything needs in order to ring. It has gravity, pulling matter inward into those denser seeds, squeezing. And it has the pressure of pure light pushing back outward, radiation refusing to be compressed. And that is the whole recipe for sound. A guitar string rings because its tension pulls it back every time it's plucked. A drum skin rings because it's stretched, taut to ring. A thing needs something pushing back. Here, the pressure of light was that something. Pull in, push out, pull in, push out. That is an oscillation. That is quite literally a sound wave, regions of the universe compressing and rarefying over and over. The whole cosmos ringing like an instrument. Sound moves through it at about half the speed of light. Picture what that means. Not a wave on a pond, a wave in everything. Whole regions of the young universe, larger than you can hold in your hand, gently squeezing together. then easing apart, then squeezing again, slow, enormous, patient, a tide in a sea that was the whole of existence. Now, you have actually seen this before, in miniature. Scatter fine sand on a metal plate and drive it with a stone. The sand flees the parts that are shaken and gathers where the plate holds still. And out of pure vibration, a pattern appears. Those are Chladni figures, a standing wave made visible, sound taking a shape you can see. A plate is a two-dimensional surface. The wave stands across it and draws its figure. The early universe was the same physics, with one more dimension, a three-dimensional standing wave, ringing through all of space at once. Every point in space ringing and falling in step with its neighbors, obeying the same simple rule that moved the sand on the plate. The math here is not a metaphor. It is quite literally the same math. So when those texts said the world is sound, they were reaching for something with their intuition that turned out to be astonishingly close to the mark. The infant universe was not a place that contained sound. For a while, it very nearly was sound. Many cultures across the world, in Australia, in the American Southwest, across the Pacific, who say the world was sung into being, that the ancestors walked across an empty land and sang, and where the song went, the world came up behind it. Rivers, ridges, every living thing called up by name, in the right order, in a melody. A song is more than a sound. A song has structure, notes in a relationship, a low foundation and higher tones layered on top. And here is the thing that still amazes me. The ringing of the early universe was not a single pure note. It was a chord. You see, when fluid rings, it doesn't ring one way. It rings at many scales at once, a deep fundamental, the largest, slowest wave, and on top of it, a whole series of higher overtones, faster and finer. And there was a limit to how large that deepest wave could be. Sound is fast, but it isn't infinite. And all the time the young universe had before everything changed, a wave could only travel so far. The deepest note was set by exactly that, the farthest a sound could reach before its time ran out. Hold on to that distance. It comes back. A fundamental plus its overtones. That is what a musical instrument does. That's what gives it a voice. Let me be precise about which instrument, because the details matter. This was like an organ pipe, where the overtones line up in a neat whole number series, not like a bell whose tones clash. And I should be honest about what it sounded like. If you could have been there, which you couldn't, neither was I. It was not a sweet, clear note. It was vast and low and rough, closer to a roar than a song, a descending rumble as the universe expanded and the pitch dropped away. So low that even now, if we try to bring it into the range a human ear can hear, we'd have to raise it to something like 50 octaves. But rough as it was a chord, a fundamental and its overtones, ringing together, a structure, almost a song. And that structure is the key to everything, because those overtones, that exact pattern of deep tone, deep note, and its harmonics did not fade away. They got written down permanently. And in a moment, I'll show you where. For nearly 400,000 years, the universe rings and stays a fog, too hot for light to travel. Every ray of light trapped, scattering, going nowhere. And then it cools past a threshold, and everything changes in an instant. The temperature drops enough for the first atoms to form. The fog clears, and for the very first time, light is set free to cross the universe. Here's what's actually happening. Until this moment, space is full of loose electrons, and light cannot cross that. It scatters endlessly the way headlights drone in thick fog. But as it cools, those electrons are finally captured, pulled into orbit, into the very first atoms, and all at once, the fog is gone, and the light simply goes. The first light, the oldest light there is, still traveling nearly 14 billion years later. But it doesn't reach us the way it set out. When that light was released, it was fierce. The glow of the sky, some 3,000 degrees. Space itself lit a dull, sudden orange, like the inside of a furnace. And then, for nearly 14 billion years, the universe went on expanding. And as it stretched that light along with it, pulled its waves longer and longer and cooler. Its warmth, mostly infrared to begin with, sank lower still, down and down, all the way into microwaves. A furnace glow cooled by the sheer stretching of space into a whisper barely above the cold of empty space. That's why we call it the cosmic microwave background. It's why you can't catch it with your eyes or an ordinary telescope. You need an instrument that listens in microwaves. But it is everywhere. Right now, this second, it is falling on you from every direction in the sky. Now go back to Genesis. All of the things the first act of creation could have been. The text says, "Let there be light." And the moment the universe becomes something we can actually see is the moment it fills with light. The old telling of Memphis and the creator Ptah shapes the world and the heart and speaks it into being with the tongue. Thought, then word, then form. I'm not going to tell you they knew. They didn't have any of this. But the rhyme is hard to ignore. That we, too, when we trace the universe back, arrive at a first light. and find that we can only describe how it got structure in the language of a spoken word. And here's the quiet miracle in the physics. At the instant the fog clears, the sound freezes. Wherever a wave had squeezed the fluid dense, that light comes out a little hotter. Wherever a wave had stretched it thin, a little cooler. The pattern of the ringing is stamped into that first light, exactly how it was in the instant it was released. And that light is still arriving. So we went looking for it. We built machines and lifted them above the atmosphere to catch it. First, a satellite called COBE in the early 1990s that caught the first faint, blurry proof that the light was not perfectly smooth. Then one called WMAP that brought the picture into focus. And then Planck that mapped the entire sky in breathtaking detail. 3 machines spread across decades, each one sharper than the last, and every one of them agreeing with the one before. What you're looking at now is that map, the oldest light in existence, coming from every direction at once, and faint speck of hot cold you can see is a frozen sound wave. The ringing of the newborn universe held still for nearly 14 billion years, waiting for us to look. So let's read it, because this is where reaching becomes knowing. Take that map and measure it. Sort those hot and cold spots by their size, how large they are on the sky. And a pattern comes out. One size of spot dominates, about 1 degree across, twice the width of the full moon. That's the deep fundamental. The lowest note. And remember the distance I asked you to hold on to? The farthest that the first sound could travel before its time ran out? This is it. That deepest wave printed on the sky as a patch about 1 degree across. The lowest note of the universe turned into a size you can point to. And then, at smaller sizes, the overtones in a series, just where the physics of ringing fluids says they have to be. And I want you to feel the weight of that. We did not find the overtones and then invent a story to fit them. The story came first. The physics of ringing fluid predicts where each overtone has to fall. And then we looked, and there they were, everyone in its place. That is the moment a beautiful idea becomes a measured fact. The chord of the early universe measured in light, not imagined, not reconstructed from a story, measured off the actual sky. And they left one more mark, the loudest of those waves, the deep one, traveled a fixed distance before it froze, about 500 million light years, and that distance got locked in. To this day, galaxies are very slightly more likely to sit about 500 million light years apart than any other distance, a faint ring printed into the map of everything, the oldest sound in the universe, still setting the spacing of the galaxies, a ruler from the first light that we still measure by. So, a dozen peoples across a dozen ages looked at the beginning and said, it started with a word, a sound, a song. They had no telescopes. They weren't doing physics. By every fair standard, they could not have known. But when we finally traced it all the way back, past the galaxies, past the first light, into the fog, we found a universe that rang, that held a chord, whose oldest fingerprint is a wave, frozen in light. They were reaching in the only language they had toward this. The universe is quieter now. The fog is long gone. The great ringing faded as space stretched it thin. But it never quite stopped. That first sound is still in the light around us, still setting the distances between galaxies, still measurable tonight by anyone who looks. The cosmos is still faintly ringing. Think about that. The next time the night sky looks silent, it isn't. That silence is only a sound too old, too deep, and too vast for any ear to catch. But it is there. It has always been there. The first note, still sounding under everything. I call this channel Temple and Atom. The temple, the oldest questions, the ones we've been asking for as long as we've had words. The atom, the smallest, hardest, most vigorous look we can take at what's actually there. And every so often, if you're patient, the two of them lean toward each other, the oldest intuition and the newest measurement, reaching for the same thing from opposite ends of time. This was the first frequency, the lowest note there is, the one the whole universe began on. From here, we climb, one frequency at a time. Stay with me, and thank you for listening to the first sound.